of y f absolute e f absolute e. Okay, and this is when you justify based on just MAD. Okay, and you can do this in Excel. See how much I want to talk about. So we do this Excel thing later on. Okay, so let me talk about one more thing. Okay, we might not finish everything today, but let me select what is going to be good for your midterm thing.
เขาใส่ไม่หมดเลยเขาเล่นเรื่องไปที่เขากดที่เขา
Now we're not going to do that.
แค่นั้น
Seasonal variation,
แค่นั้น
not yet probably. Okay, so let's fast forward, okay? Because I want you to do exercise. If you have time, then we come back to it. Okay, so fast forward to the tracking signal thing. Okay. Because the rest I may have to talk about regression first before we can explain. Yeah, so tracking signal. So let's say you come up with make the decision on the forecast. Let's say that okay, I'm going to use moving average. Okay, I'm going to use exponential moving average. Okay. Then this is how you monitor your forecast. Okay, we call this tracking signal. Okay. So this is used to monitor the performance of your forecast. Okay. And the tracking signal equation is according to this equation, which is RSFE divided by MAD. So what is RSFE? Okay, we talk about that, how to calculate that. But MAD stays the same, which is the sum of absolute deviation or forecast error divided by n. So that's not the problem. So let's see how can be done. Okay, it will take you some time. So let's talk about concept first. Okay, so the concept is the following. Alright. So basically, this is like in your quality control things. Okay, this is occur a lot in QC. So basically, you're going to have this upper control limit, right? And this is going to be your lower control limit. And the line that I plot here is called tracking signal. So it means that every time this signal trip over upper control limit or trip under this lower control limit, that's like an alarm that, oh, something wrong with your forecast error. Right, the error is too high. That's why you have to go back and readjust your forecast model. Right, and you probably will review this monthly. Okay, so that's how you're going to do that. So in this graph, two things going to happen. You will either under forecast. So under forecast means that the forecast is higher than what you expected. That's why your tracking signal is positive. Or if the tracking signal is negative, it means that you over forecast. Okay, your forecast is too high, but the actual number is lower than what's supposed to happen. Right. So it means that we can still use that moving average model until it either go over this upper control limit or lower control limit. Right. That's when we're going to have problems. So sometimes we call this acceptable range. Okay, next we're going to see how we can calculate this, and then we can assign some exercise. Because you need practice. Okay, practice is the key. Okay. We talk about this, right? So it's positive. You can read this. Positive tracking signal indicates demand is greater than the forecast, over forecast. Negative tracking signal means demand is less than the forecast, okay, and so on and so on. And we talk about that. Okay, so let's see how the calculation is done. I'm going to erase this, otherwise I'll get you confused. Okay, so let me start from scratch. Right. So this is going to be given information to you. Right. So you can get this time period. This is your forecast, right? FT. And this is your actual demand, YT. So first you compute the error, right? Which is Y subtract F. Right, so Y3 subtract F3. So 90 subtract 100. For example, you got, as this is not zero, okay, my bad. The mouse doesn't move. That's why you got minus 10. 95 subtract 100, minus 5, 115 subtract 100, 15 and so on. Okay. Then this ISFE you can treat it as a cumulative error. Okay. Cumulative error. So first one is always going to be 10. Then this one you add each other. Right. So minus 10 plus minus 5, you got minus 15. Minus 15 plus 15, you got 0. 0 plus minus 10, minus 10. 15 plus minus 10 is 5. 5 plus 30, that's 35. That's ISFE. The sign does matter, okay? So make sure you keep the sign. This next one is, so this is your ET, right? Next you do the absolute ET. Not absolute ISFE, okay? Absolute ET. So what do we got here? We just only do the positive. 10, 5, 15, 10, 15, 30. Alright, that's your absolute ET. Then next, you calculate the cumulative error, but this is going to be the cumulative absolute error. So first one is 10, no problem. 10 plus 5, 15. 15 plus 15, 30. 10 plus 30, 40. 40 plus 15, 55. 55 plus 30, you got 85. Then you compute the MAD. Alright, so this is going to be equal to 10 divided by time period. So this is going to be divided by 1. Then next divide by time period 2. So 15 divided by 2. 30 divided by 3. 40 divided by 4. 55 divided by 5. 85 divided by 6. Alright, so that's how we got this MAD. Then the tracking signal is just equal to RSFE divided by MAD. So minus 1, you got it from minus 10, right? So this number, this number divided by 10. So next one is what? Minus 15 divided by 7.5. Okay. My handwriting is getting worse. And so on and so on. Okay. So next one is 0 divided by 10. Minus 10 divided by 10. 5 divided by 11. 35 divided by 14.2 and so on and so on. So this is just example on the 6th period. That's how you compute MAD and tracking signal in the 6th period. Right, got that? So a lot of steps. Right, forecast, actual, compute error, compute ISFE, absolute forecast, cumulative absolute error, MAD, and then at the end, tracking signal. Okay, and once you got that, you're going to plot it. And usually your upper and control and lower, usually we set it to 3 MAD, okay, and minus 3 MAD. Alright. So that's the common practice. So this MAD might not match this one, okay, just example. Alright. The example that you have set upper to this number, lower to this number, and then upper is plus 3 MAD, the lower is minus 3 MAD. You don't want to go above or below that number. Okay. So we can take a break now, and then we come back, we'll do some exercise. Okay.